Now we're going to look deeper into the code of the control logic. I think for this example I have one power button and two different intensity buttons, so I'm just going to make a clone of this like that. Bang. There we go. I'm going to disconnect this thing, and it's only connected to this button here. And it's decided to go, there we go. So there's the example, a power button that applies to both lamps. There's two lamps, and one intensity button for this lamp and a different intensity button for that lamp. The system itself can be described as one power button input, an intensity for the A lamp, and an intensity button for the B lamp. And that's about all we know at this moment. And if we look at it, say, I started writing out pseudocode, intermediate code, and the things we know about this system is that it's an aerograms type system. It has inputs of power, intensity A and intensity B, and it basically has no outputs. That's about all we know at this time. Let's see if I can pause this. Here. Now, okay, now we're recording. Okay, so now we're going to look a little bit deeper. We're going to look inside the component. This normally I would make this a separate diagram, but for purposes right now, because diagrams can get quite complicated. There's still the three buttons on the outside, and we know that we need approximately three parts, or that's the way I'm going to design it. Other people might design it a different way. There's a toggle part, and there's a lamp part that's called an A, and a lamp part that's called a B. And for the toggle, we didn't need to create a name because there's only one of them here. And our code now, our pseudocode, expands to say that there's parts. There's a number one, underscore one is a toggle, A is a lamp, and B is a lamp. Okay, from here, now we've plunked the three parts on. We see the part, I'm going to pause it again. Just to show how it's done, I've got the system. I've already put one toggle component in here. The system has the three same inputs it had before. The toggle has one input and a yes and a no, meaning, you know, the first time you click it, it goes yes. The second time you click it, it says no. The third time you click it, it goes back to yes. Fourth time you click it, it goes to no. And then we've got one copy of the lamp component. I'm going to make two copies of that. So here's one copy, and here's the second copy. And I noticed that I've put a name in both of them, but I'll call that one B, I'll call that one A, and I don't need a name for this one. I've put an underscore in there, which is JavaScript notation. And at this point, we know we can expand our pseudocode to say that we've got parts. There's a toggle part and a lamp part and another lamp part, and we've given separate unique names to the two lamps, and we've given a don't care name to the toggle. Now I'm going to show how to wire these up. So I've got the three parts inside the main component. I'm going to put in the wiring. In fact, I can start showing how that's done. In drawio, which is what I'm using, I just use the wiring tool. Try to prettify it. Yes goes to on, and yes also So I click way off, click back here, and I can drag another one to there. So and we connect the power to this thing there. So when we hit power once, it'll say the toggle will go to yes, and it'll send an on a true, let's say, to A and to B. And then when we click no, we click it a second time, it'll hit no. At the moment, no is not connected to anything, and that'll just get dropped on the floor. Let's connect it to something. We'll go to the off here, and click away again. Then we'll go to the off here. I didn't like that one. I'm going to delete it and do it again. There we go. There to there. Now these things are overlapping, which could be bad news. I'm going to move these over a bit. There we go. And this one could be moved over. I'm an engineer. There we go. So now we've got the yes splitting out into on, and we got the no splitting to off and off. And if I keep doing that, then I end up with this kind of wiring diagram for all these parts. And I've extended the pseudocode to contain the wiring. I'm using arrows to say from input of self, which is the system, dot power. So that's self dot power. Goes to _1.in, goes to here. That's _1 dot in. There we go. Self intensity A goes to A dot intensity, goes to there, A dot intensity. And self dot intensity B goes to B dot intensity here. Likewise, _1 of yes goes to A dot on and B dot on. Those should all be underscores, so let me try to fix this if I can. There just don't cares. We just don't care what the name is, because you can figure out the name by looking at the diagram. And I'll save it. So now self.power goes to don't care dot in. So don't care is this one. The yes from don't care goes to A dot on and B dot on, there and there. And then the no from don't care goes to the off of A and the off of B. Now we're ready to write some code. We're basically down at the level where toggle A and the lamp code are so obvious that we can write them either in JavaScript. I'm going to choose to start writing code as a state machine, just to show state machines. State machines are code writing tools that let you write structured go-tos, if you want to call them go-tos. I know go-to's a bad name these days, but go-tos are used in if-then-elses and while loops and do loops and all that sort of stuff. State machines give you a different way of expressing if-then-elses, or cond, or case statements, in fact. This one is very simple. I'm going to color my state machines purple, and I'm going to show that from this state, the toggle has two states, off and on. And when it's in the off state, it's going to call a JavaScript routine or some kind of routine, and it's going to fire no to true. It's going to fire a true into the no pin, into this pin. And when it goes to on, it's going to fire a true to the yes pin, that pin. And in fact, when we come in here, the first time we see an in come in, we start off in the off state, we go to the on. In fact, this probably needs to show a default state, and it's not showing it at the moment. Let's see if I can add one quickly. There, something like that. So the default is like that, and it'll join to, why is it? I'm not drawing curvies. I want a curved line, and it's not good. Thank you so much. That's better. No, that's only marginally better. Don't like that either. There we go. How's that? I'm gonna have to enlarge it to work on it. There we go. Take that one, bend it out a little, bend that one out a little, bend that one in a little. Now we'll go back to 100%. And what we've got is a default, this thing, a circle means, in Harold's notation, means default state. So every time we come into toggle, it starts off by being in off. And it fires true to the no pin. So it just fires a true into there. And then the system will carry that to wherever our picture showed before. I think, let's go back to here. It fires a no into here. It'll turn lamp A and lamp B, both of them it'll turn off. So that goes to off here. And the other option is that it goes to off here. And I've, okay, so we'll go to here. And then when we see an in, fire, then we'll go from the off state to the on state. And as we come into the on state, we do something. And what we do is we fire a true into the yes pin, into that pin there. And then if we see another in come in, another one from there, we come in, then we go from there to here, and we fire a true to the no pin, and so on. So let's look at this one. Now we can write the pseudocode for the state machine. So every machine, every component gets the first three things the same. So it tells it what kind of thing it is. And in this case, I've chosen to say what kind of, I can leave it alone and just say it's an AG part, or I can show that it's implemented as a state machine, as a leaf node state machine. Whoops, that's misspelled. Leaf node state machine, and has inputs in, and it has two outputs, yes and no. Now that differs from the state machine over here. Well, no, it doesn't actually. It differs from this state machine, where we had power intensity and intensity B. But if we look at the toggle state machine, this toggle component, then we see that the toggle component has inputs and two outputs, yes and no, and that's what we've shown here. And instead of putting JavaScript in here, I've decided to put state code in here. We could use xstate for this code. I am going to show in some other talk later how to actually compile this diagram into JavaScript code, suffice it to say that I can mark the states. So I've got a state off and I've got a state on, and then I've got entry code for each of them. So if I fire if I enter that state, then I call a routine like an on event in HTML, kind of like that. And then I show transitions. So if I'm from the off state and I see an in, then I do a go to on. So I look up on in the table. I do this and I fire it. And firing it means that I cause its entry code to happen. And the entry code says, run this string of code. And this string of code and that will turn into JavaScript later. And what we'll say is, we'll turn it into JavaScript call that calls a routine called fire, and it'll send a true to the no pin, however we define pins in JavaScript when we generate the code. But at this point, we don't actually care. At this point, all we're looking at is how I designed this. I can get someone who knows JavaScript better than me to write the JavaScript to represent this, but I can show them this thing and say, here's what I want you to do in JavaScript. Likewise, when I go back to here, I can say, here's what I want you to do in JavaScript, here's what I want you to do in JavaScript, and then I'm going to do copy paste and paste it here, and I want you to do that in JavaScript. And then I'm going to need some JavaScript that says, how do I hook these up? How do I make this table? You can do a table, you can use a case statement, you can use if then else's, do all sorts of things. You know, whatever suits your fancy, whatever suits the needs of the particular solution that we want. I'll pause now. And then I'm going to do the same. I'm going to look at the definition of a lamp. It's basically a class, and then we're going to instantiate once and twice here. I'm going to go to the, I just made a tab. So there's the state machine. It's a hierarchical state machine. I'll zoom in a little bit using the plus. Hopefully, there we go. So what this says is that the lamp, at the top level, the lamp has an off and an on state. And that the you can see, looking at the transitions, you can see they only look at the on and off inputs. Again, let's remind ourselves what are the inputs to the lamp state machine. They're on, off, and intensity. Right? Don't confuse those with the inputs of the Uber state machine. They're just the state machine inside this thing. So we'll go back there, and that state machine has three inputs: on, off, and intensity. And what I've tried to show is that the on state has a drop shadow on it, meaning that there's another diagram that shows what goes on inside that, and that it's going to consume the intensity input. And that intensity input won't be used at this level of the diagram. Again, what I've done is I've folded diagrams together. Normally I would, in a more interesting example, this is a very simple example, in a more interesting example, I would draw separate diagrams for each of these and then use some sort of hyperlinking between the diagrams. What I would draw on the diagram is, on a separate diagram, is the on state of the lamp, and that on state has a default input that says go to low, and it has three real states: low, medium, and high. We'll remember that was part of the way the thing worked. And every time we see the intensity button fired, we change, we go through transitions, and every time we enter one of these states, we fire a little bit of code. Again, that code, we're leaving it to a very generic term at the moment. We're just saying we'll call it a function called setLamp, and we'll pass it a parameter, which is a string, I guess. We could make it a constant if we really want it to be efficient. I don't really care. I just want someone to understand what I'm doing here. And we're going to say set it to medium when we go into that state. When we go into this state, we're going to say set lamp to a string of high. And when we go into this state, we'll say set lamp to low. And so when we go from off to on, we'll walk the default state the first time only, because it has no history H label here. And we'll go into here, and we will immediately fire the function call, or the foreign function called setLamp, and we will pass it some sort of identifier that means low. When we when we on the event called intensity, which is this thing, then we will go from here to here, and we will fire a small piece of code that says do the setLamp foreign function with the parameter medium. And likewise, if we see the intensity button fired again, we'll go from there to there, and we'll fire the setLamp function again. Now I'm going to move over and look at the pseudocode, and you'll recognize this pseudocode from earlier. And this nested state machine now, can I, oh, yes, I can, there we go. This nested state machine adds a new state where we've said the state name is lamp.on, and we've told it it's a kind of state machine-y thing. It has one kind of input. It doesn't have any outputs. It does call a foreign function called setLamp, and I don't show that on this because I didn't think it was important enough. And then it has 3 states, and it has 1, 2, 3, 4 transitions. Let's go back to the states. We'll look at the transitions in a moment. So the states are low, medium, and high, and each one has entry code. So when we enter the state low, we will do something called, we'll call a foreign function called setLamp, and we'll pass it the string low. And I've used a JavaScript ES6 notation here with a backtick, which is very suggestive that I might want to do this in JavaScript. At the moment, I've learned JavaScript or something, or a little bit about JavaScript, and I can see how to do that in JavaScript. And likewise, we have the medium state and the high state, and each one of those has entry code, and it does something. What's not mentioned here is exit code and transition. Exit code, which would be fired on the way out of the state. So if we said we're going from low to medium, and we had exit code here, which we don't, there, then as we exit the state low, we would execute the exit code, but I don't show any here. So I only show entry code for all of them. And likewise on transitions, one could put transition code, and I don't show it. Again, it's a very simple example, so it doesn't need this kind of stuff. But there's a third kind of code that might be attached to the actual transitions. So when you make a transition from here to here on this arc, then you might also you would fire the exit code for the low state. You would fire the transition code for the transition, and then you'd fire the entry code for the medium state. And we do have medium code. We do have entry code for this here. And I'll pause. For completeness, I'm going to look at 2 leftovers. There's some foreign code that I haven't talked about. Let me zoom in on it. Okay. So there's 2 foreign functions that I talk about needing, but I haven't defined. There's a function called fire and another one called setLamp. They both require a port, or this one requires a port because it's an output function. Do I have, no, not in this diagram. Here, I show it on this diagram. It shows it here. That it's on, whoa, no, this is wrong. I'll pause, I think. So the foreign function fire takes a port and some sort of data, which normally we've been sending true as the default, but we might actually send something interesting like ABC or 5, 4 or whatever, and then we call the kernel to send whatever the data was out the port that we give it. And the other foreign function that we use but don't show how to define it is setLamp, and we get some sort of value. And at the moment, I'm just roughing this in, so I want to see whether the logic is working. And so I'm just going to use console.log, and I'll print an informative string to myself saying the lamp is set to, and the value as a string shown here.